Okay, so far we've looked at polynomial division using a method which is called long division because it's lengthy, we are writing all the terms. But there turns out that there is a shortcut for certain scenarios. Okay. Now an observation from the long division method is that everything depends on the coefficient and their relative placements. Recall how in the last example from the previous video, I placed a 0x squared to keep the placements correct. So we can create a more concise notation as follows. Now you have to be careful. This method only works if the divisor is of the form x minus c, where c is any number. Yeah. So if your divisor, for example, like the previous, let me see, right here, your divisor is 3x squared minus 2x, so it's not going to work for this method, for this particular example. And it's not going to work for 3x minus 2 as well, because it's not x minus a number, but it's going to work fine for x minus 2. So again, I'm just going to demonstrate an example here. Let's see. So how we set this up is you have this polynomial divided by x minus 3. What you do is you make an mirrored L, like a box here, and you put the number which is being subtracted from the divisor. Yeah? Basically, you put c there. And then you only put the coefficients of, so x cubed is 1x cubed, 4x squared, negative 5, and plus 5. And they have to be in decreasing powers of x. Now, a second scenario is if you're dividing by x plus 2, you rewrite x plus 2 as x minus negative 2 so that the c term becomes negative 2. And if you have something missing, again, we use the same trick of rewriting it as 0 times x squared. So you have to make sure that you have, for example, if it's cubed, then there's going to be 4 numbers here. Okay. Now I'll show you how to do the actual division. Once you've written down, once you've set it up, you draw a long horizontal line, and then you copy down the first number as it is, 5. Then you multiply negative 2 with 5, and you place it here. That's negative 10. Then you add them, and you get negative 10, and then you repeat. You multiply negative 2, and you put it here. Negative 2 times negative 10 is 20. You add, you get 26. Repeat, negative 2 times 26, negative 52. Add them up, and that should be negative 44. And then you box this off, and we're going to say that that is the remainder. Now we need to make sense of what these numbers mean. Now these numbers are the coefficients of the quotient. But what about the powers of x? Where do that start from? Now it always starts from 1 less than the highest power. You have an x cubed that you're dividing, so these are going to be 5x squared minus 10x plus 26. So you see, it's a much shorter method than the one that we did before. But again, caution, it only works when you're dividing by x minus c. Let's look at another example. So first step is set it up. So make sure you fill in the missing terms, 0x squared minus 7x minus 6. Rewrite this as x minus negative 2. So now you have negative 2, 1, 0, negative 7, negative 6. Copy this down, multiply negative 2, negative 2. Multiply 4, negative 3. Multiply 6, 0. So the remainder is 0, which means that it divides evenly. So the quotient is 1x squared minus 2x minus 3. This means I can write x cubed minus 7x minus 6 as x plus 2 times the quotient, which is x squared minus 2x minus 3, because the remainder is 0. This gives us a really useful tool that we're going to learn in the next video, which is called the remainder theorem.